So we're going to do this last bit on solving modulus problems. And really this last exercise from chapter 2, which is exercise 2G, it really just kind of pulls together all of the things that have happened so far in this chapter. And I have added in a part D to this question because this is the most common thing that happens in the exams. And actually we've done a question like this right back in our first lesson on this to begin with. So here we have got, it says, given the function f of x equals 3 brackets x minus 1 minus 2 with x as a real number. First of all, it wants us to sketch the graph, then to state the range, then to solve an equation, and then to do something with a range of values that we've got here. So there's a few different ways that we could think about this. The way I would think about trying to sketch this graph is that this looks like a modulus graph that has undergone some transformations, okay? It looks like a modulus graph that has undergone lots of transformations. Now, personally, I would just build it up slowly with doing lots and lots of sketches to be able to get to the final product of what I'm looking for. I wouldn't go in with just 1 or 2 sketches. I would probably do many sketches of this one. So I might just do some small sketches to get me started. I would draw modulus, y equals modulus of x in this first one, which just looks like a what? Like a V shape. Okay, so y equals modulus of x looks like this. The next thing I'm going to do on my graph over here is I'm going to build up getting to this picture. I'm going to do y equals modulus of x minus 1. What's going to happen to that? It's going to shift to the right by 1. Okay, so the graph is now going to be looking like this, where it's crossing at 1 and 1. And then what's the next thing? Am I going to subtract 2 or am I going to multiply it by 3? I'm going to multiply it by 3, and that's just to do with BIDMAS. Okay? If you just think about how you would calculate this, you take your x value, you're doing the shift and the modulus, then you're timesing it by 3, then you're subtracting 2. So I should expect to see multiple graphs when you do this. If you're multiplying it by 3, what is going to change about this graph? What's it going to look like? It's a stretch in the y direction. So instead of it being a V that's kind of like a flat V, it's going to become like a spikier kind of V. So instead of it crossing here at 1, it's going to be crossing at 3. But it's still crossing here at 1. And then the last part of the graph, this is my 3 modulus of x minus 1. My last one has got the subtract 2 at the end, which means what? What's the subtract 2 at the end of the whole function? Moving down 2, because it's not affecting the x, it's affecting the overall thing of the y. So it's now going to shift down 2 spaces. So if it's shifting down 2 spaces, it's no longer going to cross at 3, it's going to cross at 1. And it's still going to be that kind of spiky shape, like this. And we can probably say what the coordinate of this spiky bit is. The x coordinate is 1, the y coordinate is minus 2, because it's shifted down 2. Now they might ask you to find out these other points where it intersects the axis, but for now I don't think we need to do that, okay? For now I'm quite happy with how it looks like this. If you wanted to find out where it crosses the x-axis, what do we do to find out where it crosses the x-axis? We make y equals 0. So you would make y equals 0 here, and then you would solve the equation, and you know that there's 2 places. So that's what you would do if they asked you to find out these coordinates here. You would say y is equal to 0, and then you'd solve the equation to get 2 solutions, and it would correspond to those bits that you've got there, okay? So we're actually going to go and have a look now at the range. So do you see, that's funny, that part A of the question, I've drawn 4 sketches just to be able to get to what it looks like. I'm kind of thinking we probably should do these intersection points now, but you know how to do it. I'm not going to spend the time. Pardon? You would do it with the positive line and the negative line. So you'd solve the 2 equations. You'd solve 0 equals 3, x minus 1 minus 2. And you'd solve 0 equals 3 minus x plus 1 minus 2. You'd solve those 2 equations to find out x, and it would give you the 2 intersection points that you've got there. Okay? The next part says to state the range of f. So remember, I didn't even label this. This is y equals f of x, which is 3 modulus of x minus 1 minus 2. The range of this is saying what y values can you achieve from this graph. What are the y values that you can get from this graph? Yeah, the smallest thing you can get is minus 2. because you can never get anything that's below that part of the v section that we've got there. So the range of this graph, because we're talking about the y values, we're talking about f of x, is that it is greater than minus 2. Could it be equal to minus 2? It could be equal to minus 2, so it is going to be greater than or equal to minus 2. And when it uses this word state at the beginning, it doesn't mean you need to do any calculations. If it ever says state in the exam and you know the answer, you just write the answer down. It doesn't require any working out if you don't need to. You might need to do some just to figure it out. And then part C of the question says, solve the equation f of x equals a half x plus 3. So a half x plus 3. I'm actually going to draw this graph out again because I think it's going to need to be a little bit bigger for me to see what's happening. So this is 1 here, and that's my y equals f of x. How do we solve equations like this? What do I normally say we need to do at the start of this kind of question? Amina, what would you normally have to do if you were going to try and solve f of x being equal to this? You draw it on. So it's a half x plus 3, meaning it's crossing at 3, and it has a gradient of a half. So it's going to cross somewhere up here, and it's going to be that kind of line like that. Just roughly, you can see that it's going to be crossing in 1, 2 locations that we've got there, okay? So we just think about the two different branches that we've got. This branch looks like it's the positive branch of this bit. This branch looks like it's just going to be y equals 3, x minus 1 minus 2. And this branch looks like it's going to be y equals 3. Instead of it being x minus 1, I'm going to negate it. I'm going to take the negative part of it. That's minus x plus 1 minus 2. And this line we've just drawn in is y equals a half x plus 3. So it's just going to be some algebra now. I'm going to solve these two as a pair, first of all. So a half x plus 3 equals 3x minus 1 minus 2. So that's a half x plus 3 equals 3x minus 3 minus 2. So that is going to be 6 minus 2, which is 4, equals 3 minus a half, which is 5 over 2x. So x is equal to 8 over 5. I've gone a bit quick there, just because I'm conscious of making sure we finish everything before break time. And then I'm also going to solve these two equations together to find out this point. Any questions on this before I keep going? Because I've gone a bit fast. Where did the which bit, sorry? The 4 comes from the 3 plus the 3. Oh, I've done it wrong. So that's why no one's told me I've done it wrong. Thank you, Shahan. So it should have been what? 3 plus 3 is 6, plus 2 is 8. So it should have been 8 equals 3 minus a half, which is 5 over 2x. So it should be 16 over 5. Yeah? So x is 16 over 5. Thank you, Shahan. So this is telling me that this x coordinate here is 16 over 5. And then I'm going to do the same again, but I've just negated the bit that was inside the modulus. So it's going to be a half x plus 3 equals 3 minus x plus 1 minus 2. So that's minus 3x plus 3 minus 2. So 7 over 2x equals minus 2. And so x equals minus 4 over 7. Pardon? I just cancelled the 3's from both sides. So these are our solutions. I'm happy because one's negative and one's positive. That's kind of what I was wanting to happen, to be able to find out where it crossed. And the sketch helped me realize that it was going to cross in 2 places. Now, there's something different it asks here. Part D says, find the range of values of k for which f of x equals a half x plus k has no solutions. Now, if you remember back to one of our homeworks, we actually went through a question that was like this. And so I'm interested to see if any of you can remember about how you think we can find out when it's talking about a range of values of k for this. Ariful?
But then it's on a gradient, so it's, I think y has to be -2, and then it's just so.
So yeah, what we're going to do here is actually I'm going to just draw our attention back to this graph. It's asking for where there is no solutions. So the best way to solve this problem is not to try and find out where there are no solutions, but instead to try and find out where there is one solution. Because there is going to be one place where this graph, which has got a gradient of a half, but at any kind of intercept, gradient of a half means it's going to be a line like this one that we've got here. This, you see this half x plus 3? We could move it down anywhere. But if I find the place where it just crosses it one place, that's the critical part, where if it goes above that line, there would be 2 solutions, like here and here. If it's exactly at that line, then there would be 1 solution. If it's below that line, then it wouldn't cross at all because it wouldn't go anywhere crossing that graph. So that means I'm going to actually find out instead for part D, I will find where there is 1 solution. That's what I'm going to do to begin with. I'm going to find out where there is 1 solution. And that is actually going to be, if I come back to this graph, that would be where it's going through this point here. And we said that this point was 1 minus 2. We have 1 minus 2. So the line y equals a half x plus k must pass through 1 minus 2. And if it passes through 1 minus 2, I can literally just substitute in x and y into that equation. So I get minus 2 equals a half times 1, which is just a half, plus k. And so k is equal to minus 2 minus a half, which is minus 5 over 2. So if k was minus 5 over 2, it would be this dotted line that we've got here, and there would only be 1 solution. But the question says find the range of values of k for which it has no solutions. So k is less than minus 5 over 2. And the reason it has to be less than is because remember that k is representing the y-intercept. So if we reduce the y-intercept, this dotted line, if it brought down the board, it just wouldn't be crossing the graph at all, so there would be no solutions for that one that we've got there. Okay? We've got just a couple of minutes. I wonder if we can just do that last example so that I can at least send you away to do some practice. Because I'm conscious with some people out of lesson, I'm trying to get as much done of me teaching in the class so that I can get you to do some practice at home, and then we can come back and go through the ones we couldn't do. Okay? So yeah, try to, if you're ever doing them with these modulus graphs and they're trying to get you to do a range, don't do a range of values. Start off by doing an equation to find out where there is 1 solution and then play around with it from there. Okay? So we're just going to do this last one together as well. So we've got this graph that has happened. There's loads of ways that we could go about doing this part that we've got here about finding the coordinates. So you may do it in a different way to me, but there's many ways you could do this. So they've told us the equation of this function, which is 2 minus the modulus of x plus 1. And they've shown it looks like this shape. Why is this one suddenly like a mountain shape rather than a valley shape? Yeah, because there's a minus in front of it. So at some point when that modulus graph was being built up, the negative meant that it flipped over from a V to a mountain shape. And we want to find the coordinates of P, Q, and R. So there's many ways of doing this. I guess the way that I would find out where P is to begin with is I think that P is like the maximum point. So when I look at this, and I want this whole thing to be as big as possible, can you think about when p would be as big as possible? It kind of reminds me a bit of completing the square. When x is -1, this thing will be 0, which is the smallest this can be, because this can never be a negative number. And y would just be 2 minus 0. Y would be 2. So that's one of the ways you could think about this. I would say the other way you could think about this is literally just starting with the graph modulus of x, and then drawing modulus of x plus 1, and then drawing modulus of x plus 1 made negative, and then drawing plus 2 onto it as well. So you could draw it, and it would help you find out where some of these things are. My way of thinking about this is that the max point is when x is equal to -1, and y would be equal to 2 minus 0 is 2. So the coordinates of p is -1, 2. And the thing I'm happy about that is it looks right as well, doesn't it? It looks like x is in the right place, so it all seems to be okay. So that was for what the p coordinate is. The q coordinate is really, really, really easy to find. I would say the best way of finding the q coordinate is what do you think is the best way of finding the q coordinate? We could do the drawings, but I think there's a really quick way for this one. Yeah, look, you know at q that the x coordinate is 0. The only thing is we don't know what the y is. So if we know for the q coordinate that x is 0, to find out what y is, we can just do 2 minus 0 plus 1. So that's just 2 minus 1, which is 1. So q is 0, 1. And again, if you wanted to for r, you could do this like sketching process if you wanted. But I think maybe I might find r in a different kind of way. I would just make y equals 0. So if y is equal to 0, you've got 0 equals 2 minus modulus of x plus 1. And then you can just test it out with both of them if you're not sure which branch that it's referring to. But do you think it's going to be 0 equals 2 minus x plus 1, or 0 equals 2 minus x minus 1? I think it's the first one, because the gradient is negative. This one, what's going to be the solution to this equation? You can tell me without even having to work it out. No, without having to work it out. What's the solution to this equation? Use the graph. -3. The solution is -3. Okay, so if you did do both of them, you could decide which one was the one that made sense for afterwards. So we have -3. Okay, so this one, when we solve it, we've got 0 equals 2 minus x minus 1. So x equals 1, which means that the coordinates of r are 1, 0. So we have p, q, and r. And then part D of the question, I might leave you just to have a go at that, because we've only got a couple of minutes left. We want to solve that f of x is equal to a half x. If f of x is equal to a half x, we've worked out that this is 0, 1. We do the sketch like Amina said earlier on. So I'm going to do a sketch of it being a half like this. And it's not clear if it's necessarily going to cross this branch, but you'll find out if you get a solution for it. So I might let's try it. I think there is going to be a solution, because the gradient of this is 1, and the gradient of that is -1. So if this one is steeper than this one, then they are going to cross. They're just not crossing on the board. They're actually just going to cross somewhere over here. They must cross because of their gradients. So for that last part, we're just going to solve the equations by doing that a half x equals 2 minus x plus 1. So we get 3 over 2x equals 1. So x equals 2 over 3. And then the other one, so that's -3 equals a half x. So x equals -6. But that's nothing new, is it? This last exercise you'll find is just kind of pulling all of these things together for exercise 2G. So I know it feels like I've gone a bit quick through these last bits of the exercises. Lots of that is because I want us to be able to start moving on to some of the other things. They're going to be the bulk of what the A-level looks like, but we needed to have these bits to get us there. These aren't a huge part of the topic. They're not like differentiation or integration that will come up with maybe 3 or 4 questions in the exam paper. There may be like one question with something to do with modulus, or it may pop up in another topic. So that's kind of why we've looked at it like this. Because the bell is about to go, I'm going to just think about what I want you to do for homework on Show My Homework, and I'll just type it in there. It's not going to be, it's going to be mostly stuff from 2F and 2G, okay?